Right, let's stop at the top of the hour. Just realized I was on mute. Brilliant. So, welcome to the next vBrownBag. This is my first time coming back and hosting this for a bit. So tonight on the vBrownBag is Michael. I don't want to try and pronounce your surname, Michael, just in case I pronounce it incorrectly. So Michael's going to be giving us a closer look at Kubernetes. It's obviously something that has become really popular. A lot of stuff also with VMware and a lot of stuff we do around the pivotal container system, PKS, and using Kubernetes. That's why the K in the service is from Kubernetes. As per usual, if you want to write or tweet anything to us, you can use the @vBrownBag Twitter handle, or even the @vBrownBag EMEA Twitter handle. I'll be keeping an eye on that. Also, if you want to write anything or comment about it, you can use the hashtag vBrownBag. As you may or may not be aware, we've got quite a number of vBrownBags. So we've got the Asia Pacific one, so that's every other Thursday at 10 p.m. New Zealand time. We've got the EMEA one, which is this one, which is, we try to do at least every Tuesday, although we're not as great as we try to be. We try to do it every Tuesday, 7 p.m. BST. And then we've got the Latin America one on a Thursday at 7 p.m. Pacific time, and the US one, 7:30 on a Wednesday Central. But very recently, I'm pleased to say there's the new Brazilian vBrownBag. So the Brazilian guys have now started up their own, speaking in Portuguese. So that will be every other Monday and 9 p.m. GMT -3. So I don't know what exact times on that GMT -3 falls into, but yeah, if you're in the US or in South America, then I think that's going to fit in quite nicely. So yeah, definitely if you're Portuguese speaking, either from Latin America or even Portuguese speaking from Europe, then I would encourage you to participate in that. That should be really great. Another Latin American one where the guys speaking Spanish is very popular. Apart from that, I haven't got much else to really cover. I don't want to utilize too much of the hour from Michael. So yeah, I'll give the reins over to Michael and just say thanks for presenting for us, Michael. It's always nice when people want to present on the vBrownBags.
Thanks, Greg. Is the audio good? Can you hear me good?
I can hear you perfectly fine. Yeah, you're not muted like I was in the beginning, so that's always
good. I was actually thinking the call dropped because it was top of the hour and then nothing. So
yeah.
It's all
yeah,
good.
I was really good at starting at the top of the hour, and then I changed it, and then noticed I wasn't talking. So that was very helpful of me.
Yeah, funny thing. So now let's kick this off. Thanks, Greg, again for this kind introduction. Today it's part 2 on Kubernetes, or on our 3-part Kubernetes series. Last week I presented with Bjorn Brunert, one of my very valued colleagues, and last week we kind of focused around some of the history around containers and container cluster management, as well as solutions VMware has to offer in this area. And this week we are on this part today, we are going to focus a little bit more on Kubernetes, which we just briefly touched last week, and give you some history around Kubernetes, where does it come from, where is kind of the history behind this container orchestration system, as well as talk a little bit more also about container cluster management, which has some details that you might be able to apply to other container orchestrators as well. For example, Apache Mesos with Marathon and Docker and Docker Swarm. And next week, we were lucky to have Yves Fauser presenting on Kubernetes networking. I would consider this to be a very deep dive on Kubernetes networking and some of our solutions around VMware NSX. Today, I've seen some chatter on Twitter about this is going to be a deep dive. I would not consider this to be a deep dive. Maybe some of the folks online are considering this to be a deep dive. It always depends on where you come from and which kind of experience you have with Kubernetes already. But I think this is a great, it could be a great start into some more advanced like vBrownBag sessions around Kubernetes, like for example, storage offerings, and so on. And we have some, I think we already did some good sessions on Kubernetes from the US folks, and you should find some of them, I think, in the recording session of the vBrownBag community. All right, so let's kick things off. We have like 55 minutes left. In the case there are questions, just bring them in, just call in or put them on chat, and I'll handle them as they come in. That's no problem for me. And then if we don't make it through the whole content, I have some demos prepared, but if we don't make it, we'll just make it another session sometime later. So the typical disclaimer, all the stuff going to be presented is just not true. Just kidding on this side. I don't think we really need a disclaimer because it's all about open source Kubernetes, so no secrets here and no forward-looking stuff. First of all, we are going to kind of do a recap of part 1 last week, just a quick recap for those who did not manage to join or watch the recording. And then we are going to spend some time on container cluster management and orchestration, kind of the speaking a little bit more abstract around those type of systems which Kubernetes falls in, but more broadly, so you can apply to other systems in this category as well. Then obviously we're going to talk about Kubernetes, Kubernetes history, architecture, as well as, and I think this is pretty critical, what makes Kubernetes so unique, and why is there so much noise around Kubernetes these days. I think Docker just announced today that they will also kind of support Kubernetes as a container orchestrator within their CE and enterprise offerings. And then if we have time, we're going to look at some real world examples I put together just to show how to, like, which capabilities you get with Kubernetes, some of the very strong primitives that you get from the platform. If we have time, I'm going to show them. I think we'll just be able to talk about them and maybe have a look closer after in another session, perhaps. All right, last week we discussed that this digital transformation buzzword is everywhere. It's driven by disruptors and the need for enterprises to innovate or at least to respond, and it's real. So there is a driver behind why we're all doing this, and this is coming directly from the business. So developers are pressed to ship more frequently, to create better experiences to users, to get better insights back from users. So a much more more business to consumer focus from enterprises than it was in the old days, was a business to business focus. And so they want internally from their IT departments, they also expect kind of on-demand self-service experience to just consume services to build their cloud native applications. What are cloud native applications? I don't think this kind of those characteristics are enough, but we usually consider cloud native application to be like an always on 24/7 service that never goes down, which is robust to kind of change, or kind of services underneath it coming and going and responding to failure instead of just failing and giving up. It should be scalable, horizontal, as well as vertically scalable. It should be decoupled from the underlying platform, not too much coupled between the infrastructure layer and the application itself. And the main goal is to make it easily changeable so that you can ship more often and basically move away from a very monolithic, large kind of application into more fine-grained services. So very briefly, I don't think this is quite correct around cloud native applications. There are more definitions online if you want, but those are some of the characteristics that we usually see. And then kind of standing on the shoulders of giants, enterprises leverage containers and container orchestration these days to actually package their applications and ship them, kind of have a new abstraction format. And those tools and technologies have been like built or used and internally at the digital pioneers like Google, Twitter, and so on, and now either have been open sourced or have been created as an open source project built on the experiences some of those large and the digital natives have collected in the last decade, so to say. But also there's new roles and responsibilities emerging with this kind of a platform engineer that we briefly touched on last week. And I also saw a comment yesterday on Twitter that we might need to talk about platform engineering as a discipline, as an engineering role more maybe in another vBrownBag session, because we think that it's pretty critical also for the VMware community to get familiar with kind of those new requirements in this area, to understand what's going on and support the business. And the platform engineering is a critical part in this around the culture and processes in the enterprises. Yes, and lastly, building on the software-defined data center as a standardized building block, so to say, that you can just consume from VMware's offer solution to support IT operations as well as developers on this journey. And we mentioned it last week with the VMware Pivotal Container Service being the enterprise Kubernetes offering from VMware. All right, quick recap. You can always watch the recording, so this was just a very, very brief and fast recap from last week. On container cluster management. So this is a nice tag that you might have already seen everywhere, talking about microservices, distributed systems. It's not that easy to build a distributed system. And eventually what you're doing with a microservices architecture, or when you kind of decompose your monolithic application into more fine-grained architectures, you go in a highly distributed system. And the question is, how are you going to deal with all those challenges in a distributed system, or that arise from the characteristics of distributed systems? And just a side note, I just came in from a customer workshop today where we spent significant of time today to talk about how Kubernetes as a platform enables developers to a little bit more easy write distributed systems. It's pretty tough and hard to write a distributed application, but Kubernetes can take some of the burden off from the developers, and we'll have a look at this. So what you basically end up in is in a microservices architecture, which developers love these days. So we're going to talk about microservices. You kind of end up in the Death Star architecture. I think Adrian Cockcroft coined this term, where basically every service talks to all the other services, and you have lots of stuff going on, and somehow you need to visualize and monitor and observe what's going on. And it's not just the monolithic Java file or WAR file that you're going to look at and inspect. It's suddenly all the stuff is distributed in your infrastructure or in a cloud infrastructure, and you have to find out ways to monitor and see what's going on, especially in case of failure. So there arise a lot of challenges that have to be addressed when you go distributed, and this is by no means a full list, but it's just some stuff that came to my mind that developers and operators have to deal with when it comes to deploying or developing distributed systems. We're not going to cover this list. There's lots of stuff in there. Go and Google for it. You will see many times you will see a name popping up, which is Leslie Lampert, who has been very pioneering some of the work in there around distributed consensus with the Paxos algorithm. And there's lots of other stuff that needs to be covered in a distributed system to get it right in a way that you usually have, or you get used to when dealing with the monoliths, where each procedure call basically is within the same binary or within the same node, and now suddenly you distribute all the calls across a network, which is not reliable or not as reliable. So how are we going to solve this problem? Usually in computer science we use abstractions. So if you can't directly solve a problem, just abstract it away. As easy as it is. But what is the right abstraction layer, and are there maybe already layers that we can leverage? And I think in the 90s it was there, people were trying, or maybe even earlier, people were trying to build a distributed operating system, like a operating system just for the data center with all the capabilities a operating system has. And this was not an easy undertaking, because now you had to deal with all those challenges in distributed systems, trying to abstract them away for the application developer, running some middleware components or some distributed POSIX or etc. And this was pretty a very highly proprietary approach, and it also required the application developer to kind of take some of the stuff into account when developing an application, and so it never really came, or it never really made it as a generic approach or platform. Are there any other approaches that we can take? Well, just look at Google, because very often we see internet giants like Google and Amazon and Facebook having already solved this problem, because their way of building and running applications is inherently distributed, because they act on a global scale. They usually come from an infrastructure environment which is not as reliable that enterprises are used to with running enterprise storage arrays or enterprise server components. Usually, like Google started with PCs. And so right from the beginning, they kind of had to think about, okay, if my infrastructure is not as reliable, then somehow I have to deal with the stuff in my application logic, and make the application just smarter so infrastructure can be dumped. So what they came up with after some time is a generic approach for Google, where they looked at their data centers as just a big machine, a big computer, nothing else. Do not manage node, manage data centers, or even multiple data centers. And you can read more about this, the idea behind this in the online ebook, The Data Center as a Computer by Barroso and Hölzler. And I think it's a pretty good read. It tells you a lot about infrastructure operations and platform technologies that Google, the kind of decisions that made it into Google's platform, but it also kind of gives you some idea that you can perhaps use in your daily life at your enterprise. So how will it look like with the Google infrastructure for everyone else? So besides virtualization, because Google does not really use kind of standard virtualization, everything is custom there. But just moving away from the Google-centric approach, we have this hardware which can change, which can be HP, which can be Dell, because you're not Google, you cannot design your own hardware, so you have to buy it from somewhere, and you have to kind of make it standardized, make it a building block, and abstract it away. So the first kind of abstraction that we use usually is virtualization, to make the heterogeneous pool of hardware, be it storage, network, and compute, just appear as a large infrastructure resource pool that we can consume. And this is what you guys all know about. Now we got the operating system, like the virtual machine, running in there, and all of a sudden we have this new component, which is the container runtime that we talked about last week. The container runtime also offers us a nice and new abstraction, because it acts on the local node. So it's not a distributed operating system per se, it's still on the local node, but it exposes a kind of standardized API or mechanism now to deploy applications. Oops, wrong button, sorry, just to go back. But in order to manage clusters or data centers and not machines, we have to have some kind of orchestrator or cluster manager on top of this, which obviously Kubernetes is one of, and which kind of abstracts, again, is another abstraction layer, which abstracts the nodes, the operating systems, the virtual machines away, and makes it consumable, make a large resource pool, again, on another level, available to the application developer or to the delivery pipeline. And on top of this, we have the standardized format being a container, which then is going to be executed on the container runtime on the local OS, managed by the container orchestrator. And again, this is the abstraction that has been kind of missing in the very proprietary distributed operating system approach that we just talked about later. Now with Docker, with the container format and the different kind of containers runtimes that we actually have an abstraction which is application centric or close to the application, and just has to be managed by an orchestration engine. Some of the tasks that an orchestrator has to do, like from a 30K feet view, it's doing obviously scheduling, so moving workload or accepting workload and then putting it on some node that nobody with an Excel sheet has to sit down and note where the container goes, so this is obviously a task of the container orchestrator. It should be doing scaling and HA, so if a container dies, just restarting it and reacting to node failure. So all the stuff that you usually use from your local operating system, like if a process dies and you have a watchdog on it, it will just restart the process, the application will come up, or the networking and the storage management, or on which kind of processor your application should be started. You're not getting asked by your operating system, like Windows or OS X is not asking you where would you run Word now. It's just doing it. And so kind of the same applies to a container orchestrator. It tries to abstract all the low-level kind of creating and maintaining and lifecycle around the container to make you focus on creating value by writing application code and not focusing on the plumbing. And there's a lot of other stuff that usually container orchestrators offer around user management, monitoring, diagnosis, and so on. They are all on. So just getting back to last week, we talked about Nomad, or we mentioned Nomad, Docker Swarm, Kubernetes, and Mesos and Marathon. They all have some kind of different approach to this, and some might be better at authentication, authorization, and accounting, and some are perhaps more advanced in terms of scheduling. But basically, this is what they all cover and what a container orchestrator usually has in focus. And a typical architecture, and this is what we just briefly touched last week, and I'm going to spend some more time today. We have the masters, usually 3 masters for quorum. Very often we see 1 being the leader and 2 being followers, so it's not an active-active, but more kind of an active-passive. This is because of some of the quorum and consensus mechanisms these systems apply internally, which you can also read in like the Paxos paper of Leslie Lamport and some of the papers around Kubernetes and Mesos. And then they do the scheduling, they do the resource management, so managing the nodes and abstracting the nodes, kind of what vSphere does for infrastructure resources, those container orchestrators do for container hosts. Then they have some service constructs, service meaning how to expose an application or a service to the outer world, make it a stable endpoint, and then obviously offering some kind of API and user interface. Most of the time, excluding Mesos, all the master components are stateless. That they don't keep state, especially if we talk about Kubernetes. Where do they keep state? Usually in some kind of key value store like etcd, console, or Zookeeper. Mesos also uses Zookeeper in the backend, but the Mesos masters also have kind of a local registry where they replicate state. So this is a little bit different. But Kubernetes and Docker, for example, Docker uses an internal key value store that they ship with, but Kubernetes uses like etcd as an external hook into, so it could be replaced or swappable at some day, but at the moment it's etcd. So Kubernetes architecture is pretty stateless on this side, and the state is in the etcd. And then we have we have the nodes again around etcd or Zookeeper, which are also usually in a leader follower. You can run those Zookeepers, etcds within the same master components. Actually, that's recommended now with Kubernetes, but in like the old days, we've been running etcd in another set of machines than the master components of Kubernetes, for example. And the last thing is the agents, the workers, where the containers are eventually deployed, running a container runtime. We're going to look at this a little bit closer in the Kubernetes section, but at a very high level, Swarm, Nomad, Mesos, and Kubernetes, they kind of have the same architecture, and it just sometimes the distributed key value store is within the master component. Sometimes it's externally that you can just hook into. Greg, any questions so far? Just asking. You quiet?
Yeah, sorry, I was on mute. No questions so far.
That's good. All right, let's continue then. Just a note on scheduling, and this is where, like for example, Mesos and Kubernetes kind of diverge. Scheduling in computing is a method by which work specified by some means is assigned to resources that complete the work. Pretty generic, pretty abstract definition, but at the end of the day, it's if a container comes in or has to be scheduled somewhere, how does the container orchestrator deal with it and manage this? And there are kind of different approaches to scheduling in some of the container orchestrators that we just talked about. And there are more. It's just three of them, three of the architectures that I picked from a presentation of Malte Schwarzkopf, which I recommend watching you from Container Days last week. There's the monolithic approach, which you could think about, for example, vCenter. So if we just leave the container world now, vCenter is a monolithic scheduler with DRS because it's kind of inbuilt within the same binary, and it ships with the vCenter. It's not like replaceable, or you can hook into your own scheduler, and it just comes with the overall architecture or with the master component in this area. And we've got the two-level approach, which Mesos falls into. So Mesos is a resource manager, and that's why you usually see Mesos and Marathon being mentioned. Marathon being the scheduler, one of the schedulers here, and getting resource offered by Mesos. So Mesos basically is the kernel, the resource manager, and then Marathon just decides to accept or not accept offers coming from the resource manager. And usually in the Mesos world, you see more frameworks or schedulers running on top of this, for example, for Hadoop, Cassandra, and so on. And this is where Mesos kind of differs from all the others. For example, Kubernetes. Kubernetes is a shared state. It like in the very early days, it could be considered monolithic, but since the scheduler in Kubernetes is replaceable, or you can just run multiple schedules in Kubernetes, we kind of have the cluster state, which is exposed through the API server in Kubernetes, we're going to see later. And then you can, without any problems, run multiple schedulers in Kubernetes. And then there are some advantages and disadvantages of doing this, but essentially there are differences in the way scheduling works on these layers. And this is sometimes where the confusion comes in. What is Mesos? Why is there Marathon? And how does it relate to Kubernetes? It's just Mesos has a different architecture when it comes to resource management, and so it's perfectly fine, as we just saw announced some weeks ago, that Kubernetes is now also can also be run on Mesosphere. Well, it has been already, I think, a proof of technology, but now I think it's pretty it's something that you can try and run on. So Kubernetes is just another scheduler and framework on top of Mesos. And just some of the, maybe to make it more applicable, a queue where you don't really see if you queue up what's going on, and then somebody manage it for you, like the door opens and someone says come in, and then you take a seat. This is kind of the monolithic approach. The two-level approach, so to say, is there's a guy saying go there or go left or go right, and then you queue up. So you kind of, and you can say no, I just want to wait. Or yes, that's actually a good decision. So someone is going to like being the governor of the resources being offered, and then in the shared state, you can just, you as a scheduler, you just pick your you choose your own destiny, which could be good because you are smart enough and pick the shortest queue. But there could be also another smart scheduler coming around, also picking the same queue, and you get a conflict, and the conflict has to be resolved. So this is the stuff that you have to deal with in shared state scheduling. And in Kubernetes, if you do run multiple schedulers, this is a situation that you have to solve, or that the platform kind of solves for you in some sense. And this was just a short excursus on scheduling, which is my favorite topic, resource management and scheduling. And I thought it's might be a good fit to talk about this because Mesos and Kubernetes they have a different kind of architecture in this area. And there's other stuff going on for fairness and efficiency. So scheduling is not an easy thing, and we should be all proud of the work the vSphere team, the vCenter team has been doing with DRS, but also the community around Kubernetes was this kind of smart scheduling that's in there. It's not an easy task to do efficient scheduling. All right, now up to Kubernetes. We have almost half an hour to go, and I think we're still doing good in time. So what are the problems that we're trying to solve? From operations as well as development perspective, we want to solve availability, efficiency, and scalability. So we want to have a system that's kind of enables us to be agile, be fast, should be scalable. It should not impose any limits on the kind of scale that we have. Obviously, it should kind of be available or has capabilities to offer high availability for our components, like running on multiple systems, be it the master components or be it our applications being distributed, as well as efficiency, meaning that driving the utilization of the, from an operations perspective, driving the utilization of the nodes of the workers. And we've seen some customers running on AWS or running on AWS, running on EC2 instances, their applications, and now with Kubernetes, they put Kubernetes on top. And due to the efficient scheduling and container kind of advantages of being just packed side by side, because the application is encapsulated and they are isolated, they actually can drive utilization and thus reducing spend to AWS by reducing the number of EC2 instances they are running. So container orchestration done right can increase efficiency in your data center operations, not just from a people perspective, like one guy managing more servers than in the past, but also from a infrastructure resource usage. History, where does Kubernetes come from? And today in the workshop, we spent some time on this. Compared to Docker Swarm, for example, Kubernetes has is younger. I think it's younger, like the version 1 which came out in 2015. Not sure when Swarm made it into, but just right from the numbers, it could be like both are at least the same age. But if you look at the history, and this is where it dates back to Google and Google's knowledge around building container cluster management systems globally, they have been running containers, kind of their internal format of containers that they use. They don't run Docker. They have been building a system which is called Borg, I think around 2004, 2005, maybe. Don't quote me on the numbers, but around this time. And during the last kind of decade, Google has collected a lot of experiences and knowledge around how to build efficient and scalable container or a cluster management system like Borg is. And with the kind of rise of Docker and the success of Docker, Google created the Kubernetes project as an open source project. It could be seen as a successor to Borg, but Google internally still runs on Borg, and Kubernetes is kind of the open source project. It doesn't share the same code base, new code base, but all the experiences from Google went into Kubernetes, and some of the lessons that they learned, for example, what would they do better in Borg, looking back now for 10 or 15 years, this made it into Kubernetes. And you can look at some of the papers that I quoted here, which have much more detail around the history and the design decisions and differences between Borg and Omega and Kubernetes, especially the last one. The last blog is pretty interesting from, I think, some of the co-creators of Kubernetes talking about what they did better in Kubernetes and some of the areas that are still open and have to be kind of solved. Some of the milestones, so the kind of really the kickoff for the idea to build an open source container orchestrator dates back to 2013 when Docker kind of like the .cloud company open source Docker as a container runtime, and then everybody picked it up, and the developers were happy now to use containers, and then all of a sudden there was a need for container orchestration to run it on multiple hosts in an efficient and scalable and available way. So this is where Kubernetes hit the light in July 2015. This version 1, now we are at version 1.8 and has been released in September. And just for the name, Kubernetes is Greek for pilot or helmsman, like steering the ship. By the numbers, and this is where you can see kind of Kubernetes gaining popularity, a lot of popularity compared to, for example, Mesos or Docker Swarm and Cloud Foundry. Kubernetes is really pretty popular, so to say. This is a Google Trends analysis from last week, and some other numbers, 1,800 commit authors behind the project, 33,000 commits, still growing very fast, active community, vibrant communities. It's pretty large. One of the, I think, most vibrant projects on GitHub by the numbers. And so where does Kubernetes play in the stack? We've seen this kind of distributed operating system or abstract container orchestration level, and you might have already guessed it that Kubernetes is not infrastructure or in a virtual hypervisor. Kubernetes basically is a container platform which builds on a infrastructure as a service. So this could be, for example, vSphere or OpenStack or AWS or Google Compute Engine. So it requires resources. So it doesn't bring them up. You have to provide them in some way. And then Kubernetes takes over control, like on autopilot, and it steers the fleet of homogeneous machines. So again, abstraction, standardization. And this is one of the key pillars of Google's success, being being highly efficient and scalable, and providing those highly available applications. Standardization is very key to the Google architecture and should be also to the enterprise in order to release faster but also high quality products. And then on top of this, Kubernetes exposes an API. We're going to look at this just in a minute. And some of the most notable kind of features, so to say, is a pod in the Kubernetes terminology. A pod could be seen as a container, but it differs, or like, for example, a Docker container, but it differs in some ways when it comes to networking, but it also that a pod could actually consist of more than just one container. And usually it does, because internally there's a little hidden container running in each pod. And then when you deploy your application, and you have, for example, you have your web server, and you also want to deploy a logging server side by side this little web server. So you could make it part of the same image, making the image bigger and having a tighter coupling, which we don't want because we're building microservices. So this is where the pod comes in handy, because one developer writes the log container and the other one writes the web server container, and then you just specify in the pod manifest that you want this to be running in the same pod, sharing the same namespaces, running on the same node, being very highly efficient, doing in local host calls, not going over the network. And so the pod concept is something that Google has been using internally in Borg as well, and was pretty successful with. But in the papers, you also can read about the differences between what Google Borg did and Kubernetes does from the container perspective. So what's in Kubernetes? What do I get? There's a lot of stuff. We're not going to cover everything on this slide here, but Kubernetes is more than just a container orchestrator. So it does more than just deploy your container somewhere and then sits in the back and waits for a container to fall apart. It does efficient scheduling, and the scheduling policies can be tuned. You can add your own scheduler if you want, if you have the need for. You have auto scaling in the platform itself, but beware, this is not node auto scaling. This is pod auto scaling. So it auto scales your kind of application based on certain CPU memory metrics. It's got this replica sets, which is a control logic, a control loop, which watches your application, and if you want to have your application run on 5 nodes, then and one node fails or one of your pods dies, then the replica set will work against the desired state that you express. Also, we're going to cover this later. It's got automated rollouts, rollbacks, configuration management, storage management. So there's lots of stuff in this platform, and make sure to have a look at this presentation if you have time after reading all the other papers. I recommend it to you. It's kind of a new way of doing platform as a service. It's per definition, I would not consider it to be a platform as a service, but Kubernetes, I think, is kind of emerging more into this space, and not just being a container orchestrator moving containers from A to B. So what's in the box? What does the architecture of Kubernetes look like? So we've got our master or multiple masters, and usually these days you would run etcd the key value store within the same master. You got some microservices in there, which is the controller manager as well as the scheduler. Scheduler obviously doing the scheduling of containers or pods coming in to the platform. The controller manager contains some of the important controllers like endpoint or services controller or replica sets and some daemon set job. Much of the stuff that we just saw on this slide before is built into small microservices. So they all live within the controller manager space. And then also there's an API server, which all of those components talk to and are like kind of connected on the machine. And you would run either 1 or 3 masters in a highly available environment. On the nodes, on the workers, we've got the container runtime. So Kubernetes itself does not ship with a runtime. It just has an interface to a runtime, and it's your task to provide a runtime. Could be Docker, could be just recently announced CRIO runtime alternative, could be Rocket. It just has to be any compliant runtime as required by Kubernetes by the container runtime interface. Then there's the kubelet, which is the agent that does most of the heavy lifting on the worker. You somehow need to network those things together in an overlay network fashion. You can run the kube proxy, which comes out of the box, but you also need an overlay architecture between the worker nodes. So this is where, for example, NSXT comes in, which Eve's going to cover more in depth next week. Then usually you would run some add-ons like a dashboard, a logging system, kind of metrics exposer, which sends like health status of the workers and the cluster to a central endpoint and so on. So some of the add-ons, or for example, DNS is another add-on that usually ships with Kubernetes, like the open source Kubernetes. But it always depends on which kind of Kubernetes distribution you're using, and so this differs in some way depending on your environment. And then lastly, we kind of have the access component, which is usually a CLI, which is kubectl, the command line command, a user interface, which is the Kubernetes dashboard, and an API. And what you should be noting, first of all, those are all kind of small microservices talking over the network. So we still have Einstein and relativity applying to this. What I mean by this, we have a network in between it. So we'll leave the monolithic world where everything is good and it's paradise, and we go to this microservices world where everything happens over a network, and then the network can fail, or it can be delayed, or can be dropped, or whatever. So we are living in this world where everything is relative to the components, and we're dealing with asynchronity in the whole application stack. So this has to be considered. So again, we are running a distributed system, highly distributed system, and you have to be skilled to work with the system and build it and troubleshoot it. But something that stood out from this picture also is that the API server is a very critical component, not because it's it's a very tough or stateful system or whatever. By no means it's a stateful component within the master, but it's the component that all like workers and CLI and like even some of the master components talk to. So the API server is the central heart of Kubernetes, and this is important for the next slide that we are talking about too. All right, just a last note on desired state and declarative management. We briefly touched this on the replica set, but Kubernetes is different when it comes to the way we've been using and dealing with infrastructure as well as applications. Like in the old golden days, we kind of described every step an application takes into the infrastructure, like do it this way, deploy it there, put it there, make a network, and all the stuff has to be thought by someone and then put it in a script or in a configuration management system. Kubernetes changes this because it just requires you to express your desired state, like for example, put it on, replicate it 5 times with that amount of CPU and give it this kind of network or like service credentials or labels or whatever you want, and then let the cluster manager, let Kubernetes figure this out. So it's totally different. You would not really write a script to where your container goes and then how it's being extracted and deployed. All this stuff is done by Kubernetes, and this is what we mean by desired state and declarative management. Also, Kubernetes will make sure that it always reaches the desired state that you or the developer expressed, meaning that if you want to run 5 times your application in the cluster, Kubernetes will try to keep it always running. And if one of the components fails, it tries to restart them. This is what they usually also mean with self-healing. YAML files are usually the way that you express the kind of the configuration of your application or how it's being assembled. And then those components are highly dynamically assembled during runtime. And this is one of the strengths of Kubernetes. Everything, or most of the stuff is based on labels, like you know from Gmail. Gmail doesn't have folders. Gmail has labels. And so everything gets a label. And if you query for some label or for some combination of label, you get the results back and you don't have to deal with folders. Same with Kubernetes. Everything gets a label. And then your service is being on demand assembled when it comes to, for example, exposing the service to the outside world. And this is what we already touched, like the control loops, the desired state, which is internally built with the replica set and the replication controllers. I was thinking about doing a demo, but looking at the time, we might not make it through, I think. So let's just skip the demo for now. Let's just continue the presentation. And I think, given the depth and broad of the topic, we should make it a deep dive in another or some of the other vBrownBag sessions that we can think of this. If you find this presentation valuable or if there are any questions, I think we should do another session on some of the stuff. So if we have time, I'll go back to the demo and show some of the stuff I wanted to present on the Kubernetes side. So what makes Kubernetes so unique? First of all, and we already touched on this, Google's put into Kubernetes when they thought about the design and the architecture of Kubernetes, they put into all their knowledge that they gained from running cluster management at scale, which is more than 10 years. And you could see it as an open source successor of Google Borg, but they kind of differ in some of the architecture as well as capabilities that both have. But it's kind of neat to kind of use some of the tooling that Google some way uses internally, and that you can just run and build your fleet of machines or manage your fleet of machines with Google experience. It's like hiring Google guys doing the work for you. And this is the second one, is probably the most important one. Right from the beginning, Kubernetes has been designed to be modular, like all the microservices that you've seen in the architecture, but also extensible by the API. And this is why I put so much focus on the API server. The API server is the heart of Kubernetes. So you can replace all the other pieces because everything talks to the API. And as long as the API is kind of stable, or you kind of expose, you don't break the API, then you kind of can always have kind of your Kubernetes system, no matter what kind of etcd or Zookeeper or what else runs in the background. So it's highly extensible by having this API-centric approach. You can, and we see this a lot, customers having ideas about extending Kubernetes because there might be some stuff not being in the core of Kubernetes. So you will write your own controller, which is nothing else than a container doing some of the control logic. For example, today we talked about one of the demos that Kelsey Hightower did, which is looking through all the containers running in the Kubernetes cluster, looking for expired or soon to be expiring certificates, which is a pain from an operational perspective. So the controller would go through all the images and check for TLS certificate expiration. And if one of the pods is being affected or the images is being affected by a soon to expire certificate, we would just start requesting a new certificate, inject it, update the deployment, and we would not run into the situation where a service could not connect to the other service because of an expired certificate. So this is all the stuff that you can automate, and Kubernetes, by this extensibility and or extensible architecture, gives you a lot of power about extending Kubernetes to your own needs. And this is what, from my point of view, makes it so unique. And then it gives you some of the primitives to write distributed systems. So some of the challenges that we saw in the beginning of the presentation when we talked about distributed systems, Kubernetes helps you to deal with. It doesn't solve all of them. It's still, you still have to write good code to make your distributed system run well. But Kubernetes gives you some of the functionality like restart, self-healing, service discovery. Some of the stuff is already in the platform that you, as a developer, don't have to. Well, you have to think about it, but you don't have to implement it. You can just use it from the platform. And lastly, it's got a huge community, let alone the more than 30 special interest groups which Kubernetes has around all the different kind of topics, for example, networking or scheduling or API or service broker and so on. So alone, this shows that doing a deep dive on Kubernetes would perhaps be 30 deep dives on Kubernetes, because there's so much stuff going on, changing and focus in this platform and power on this platform, that doing this in just in a 60-minute vBrownBag, I think is not sufficient to make it a real deep dive on Kubernetes. And next week, Eve will prove this for NSX and container networking, which again could be more than a 60-minute talk as well. All right, I have some examples, and I might want to touch on them because they give you some ideas about Kubernetes. And in one of the, like, if you want, other vBrownBag sessions that we can schedule and set up, we can go like have a little bit look deeper into those examples and show what's going on and how to do it in Kubernetes. So just quickly, health checks and rolling updates. So Kubernetes gives you this power of doing rolling updates of your applications. Remember, we want to be 24/7, always on of our application. And if we update a container image, we don't want the application to be down. So we want to have it on a rolling update fashion. And so Kubernetes has capabilities to do this. You just say, okay, update this deployment to a new version, and then it will start gradually adding new versions and taking down the older ones. But this is, well, it looks easy on the PowerPoint. There's some stuff that you have to like work or implement in the code from an application developer, as well as use in the Kubernetes platform, which are the so-called readiness and liveness probes. So Kubernetes can watch your application, can watch the pod and say, okay, the pod will tell me that now it's okay to serve traffic, and then it's going to move it into the load balancer. And if it fails, it's going to remove it from the load balancer so it can periodically query the system. And so this is the way you would orchestrate a rolling update in Kubernetes by specifying, for example, readiness probes. So it does give you the capabilities of doing rolling updates or upgrades of your application, but the application developer has to put them some kind of hooks into his code to make this work, to coordinate this between Kubernetes. And I did a session at vMworld this year talking more deeply about this, but if we have some more time in another vBrownBag session, we can definitely look into this example for a while. But take from this slide that with Kubernetes, you get health checks and rolling updates for free. The second one is logging. Let's have an example where you have a container which you, for example, got from an external third party that you cannot change, and this is hard-coded to log to a specific folder, which is not nice because by this way it doesn't really follow the 12-factor principle. But let's just say this is what you get. You can change it. Now Kubernetes is not so happy about this because it, as many other systems, it expects the container to log to standard out, so it can just read from standard out. But by the power of Kubernetes and with the pods that we mentioned, meaning that you don't just have one pod or container in it, you can have more containers in there. An operator could build a little tailf example command. Let this tailf grab from the log and redirect to standard out. And now Kubernetes is happy. And this would be some of the tasks that a platform engineer or infrastructure operator could write, like extending Kubernetes just by using this sidecar primitive, adding another container, an infrastructure container or a logging container, so to say, to an application. You can inject it, you can enforce it, for example, when a container comes in. And then you can also always make sure that a container is shipped with your logging agent or whatever you want. So this example shows how to deal with some kind of code that doesn't really adhere to the 12-factor apps principles, but also shows how to extend Kubernetes or leverage the pod concept by running multiple containers within the same pod. And then Kubernetes is happy again. And the third and last one is kind of the auto scaling. But in this case, I'm talking about a kind of system that has a message queue, like a RabbitMQ or Kafka, that you get in client requests from here. They hit your load balancer in Kubernetes, and then all of a sudden, the traffic increases. And what happens is that the message queue also increases because new messages are being added. And what you want is that your system is kind of auto-adapting to this new workload or workload requests, adding more workers, so pods. These are not Kubernetes workers, these are pods. Sorry for the naming confusion. And then when the kind of requests kind of reduce, so Black Friday is done, the message queue is being reduced. Obviously, you don't want to idle those workers. You don't want to keep them. You just reduce to the number of workers that you need. So you have some kind of elastic and breathing system adapting to a custom metric. And for some time, this hasn't been possible with Kubernetes out of the box. So the Kubernetes autoscaler was just able to build on CPU and memory. Now it's been extended to also look into custom metrics. The example that I built was in the old days where you had to you had to extend Kubernetes by writing your own controller, but it was a good exercise to understand what it takes to write a custom controller. And basically it's just a little bit kind of code that you also put in as a container in the system you deploy with the application, and this watches the message queue and tells Kubernetes, hey, if the message queue is beyond a certain threshold, just give me more pods. Just by talking to the API. This is all API centric. There's no kind of create pod on node ABC. This is all driven by the API and let Kubernetes figure out how to deal with this stuff. And this is what it would look like, for example, in Log Insight. So I wrote a quick hook into Log Insight. So you have the queue depth here for RabbitMQ. On the right side, you see the queue going up and down. And this is some of the metrics in Log Insight showing how the pods are created and being destroyed. So you can also extend Kubernetes to log into Log Insight or another logging system, for example, with custom metrics that you have. For the monitoring, I don't think we have time. I'll just leave it there so you can watch the recording and push pause in this place. There was some question last week from Frank around how you would do monitoring in Kubernetes, and this is an important and also not so easy topic because monitoring is more than just doing logs. You might want to look at this PDF from our VMware Wavefront colleagues who did a nice white paper on container monitoring with Kubernetes, or you can have a look at some of the references that I have in here. But for time reasons, we need to skip. And you see that, again, 60 minutes is just not enough to do even a quick introduction on Kubernetes. All right, wrapping up. So the problem statement that we tried to solve with our kind of distributed operating system approach was solving for developers as well as operations availability, efficiency, and scalability in order to drive the business. This is what we all want. Basically, what you as an enterprise developer or operator want, you want to support a business to be more agile and be responsive to your customers. And Kubernetes helps you. Kubernetes is not like the holy grail or panacea to solve all the problems in there. There's still a lot of things that have to be added or that you need to put in your application code or you have to provide when it comes to infrastructure. But it's a great step towards more abstraction, more standardization in the infrastructure layer and using containers as a new packaging format to build and deploy your applications. And Kubernetes is actually pretty good at doing this. One last question might come out, where would I start if I want to look more into Kubernetes? Of course, there's the Kubernetes website. Our VMware Cloud Native Apps business unit has a nice channel doing some like 5-minute or 10-minute introductions to Kubernetes networking or Kubernetes pods. So they are short, snappy, to the point. Make sure to visit this channel. Katacoda is an online training platform where you just open your browser, you get a Kubernetes environment, and you can go through tutorials. Pretty neat if you want to start with Kubernetes and not have to set up a Kubernetes cluster. If you do want to set up Kubernetes on your local machine, make sure to start with Minikube. Pretty easy to set up, download, and go up and start using it. And there's also a getting started guide to actually deploy an application on Kubernetes. And also, I highly recommend Henny Michael's blog post series on Kubernetes introduction for VMware users, where he does actually a pretty good, damn good job on comparing Kubernetes to VMware concepts. So they might better relate to your experiences, the knowledge that you have around vSphere and vSphere infrastructure. And I actually thought about putting some of the stuff in here, but we just don't have the time. We would run over the time. So make sure to look at Henny's blog, which is fantastic and has some nice graphics in there as well. And this gets some bonus points from me, if you get comfortable with a programming language, and I'm actually saying not scripting language, this is a bonus point for you because Kubernetes is written Go and Google Go. So there's an advantage of learning a program language, not just to understand how developers work and what they do, but also kind of reading the source code base of Kubernetes and see what's going on in case you have questions. And I did a quick Golang training, which is a PDF and some code I put onto my GitHub page, or just drop me a note on my Twitter profile, and I can give you going with some of the Go stuff, how to start with Go. All right, this is it. I'm sorry, I'm just speaking too fast, but I made it to the point. 9:00 p.m. German time. Thanks for joining. Greg, are there any questions? Can we still have questions?
Yeah, we can. I mean, there's no questions so far, but if anyone wants to ask any, they can do.
Yes, we can.
Yeah, on the dot too. That's brilliant.
Yeah, I'm sorry for going through this so fast. I thought I would be able to do demos, but I think, Greg, if you agree, we should do more on Kubernetes in the vBrownBag community.
Absolutely. I know there's definitely some interest around, you were saying that Haney Michael one. So yeah, I mean, I think people are certainly interested in that. I know I would be, coming from a VMware background. So
yeah,
I think that would be a good idea. And yeah, I saw you starting off your demo. So I think, yeah, a deep dive on the demo wouldn't hurt either. I'm sure we could schedule that in.
Yeah, we can come up with a plan. So Hanny actually has some good content as well, and then we can build on some of the content that we have. That's good. And just as a last note, make sure tune in next week for Yves Fauser. Yves is a great resource that we have here at VMware for Kubernetes and Kubernetes networking and NSX. Awesome guy. Always great to have him on the show. Make sure to join in next week on Tuesday for the networking and for the last part of this series.
Especially the NSXT pieces. I think that'll be extremely interesting.
Exactly. Okay, I'll be hanging out for.
I don't got any. There's no questions. Yeah, but I mean, I guess people can reach out to you on Twitter if they wanted to. If they had any questions, post this.
Yeah, let me just quickly show my Twitter handle. I think it was on the.
No,
just to make sure. Yeah.
Yeah, that's the one. Yeah, the first one.
So my real name was Gun, so I had to come up with this one, but just ping me on Twitter for any questions, comments, corrections, whatever.
Brilliant. All right. And then, yeah, for those who joined there, I've recorded this and I'll get the recording up as soon as possible.
That's awesome. Thanks, Greg, again for having this vBrownBag series. Community.
No worries. And
that's
thanks
good.
for joining again, Michael.
Awesome. Okay, I'll drop up then now and give it back to you. And thanks again for joining, guys.
Thanks a lot.